Hello everyone, I'm Dr. Evelyn Reed. In astrophysics, we are accustomed to the strange. But strange usually means it will take us a decade to explain what we're facing today. Here, strange means this doesn't exist in any of our models. We're talking about a visitor. We're calling it Atlas. We've given it the polite designation, interstellar comet. And it captured our attention. In the span of 4 short months, the scientific community published nearly 100 research papers on it. 100 papers. For comparison, Oumuamua, our first famous interstellar visitor, didn't generate this level of intense rapid-fire frenzy. But here's the crux. Despite that intense scrutiny, despite hundreds of telescopes trained on it, we can no longer see it. It has vanished. It didn't break apart like a typical icy comet. It didn't fade along its projected trajectory. It simply vanished from our sensors. And that is when the unofficial data started to surface. The chatter you don't see in the mainstream journals. The stuff that gets dismissed as fringe. The whispers about its abrupt silence. So, what do we know? We know that right now, Atlas is making its closest pass by our Sunday. Its perihelion, its closest approach, will peak on October 29th, just 210 million kilometers from our star. A massive, mysterious, currently invisible interstellar object is hurtling toward its closest rendezvous with our Sunday. And we have no idea what it is or what it's doing. We are going to unpack everything, including the fringe theories. If you really want to understand what's happening out there, the real mysteries the universe is throwing at us, hit that like and subscribe button, because today we are going deep into the shadows, right where astrophysics and science fiction collide. Atlas's journey is only just beginning. As I said, Atlas is at perihelion. The moment it grazes, the Sunday, what does our data say? On October 29th, it will be 1.4 astronomical units, AU, from our star. To give you perspective, 1 AU is the distance from the Earth to the Sunday, so 1.4 AU places it just inside the orbit of Mars. To be fair, this isn't a sun grazer, it's not plunging into the Sunday, but for an object arriving from the cold dark of interstellar space, this is the moment of truth. This is when it will be at its hottest. This is when its activity should be at its absolute peak. Any comet approaching the sun undergoes sublimation. The dirty ice on its surface, solid for millennia, vaporizes directly into a gas. There is no liquid state in a vacuum. It's this sublimation process that creates the spectacular show, the coma, a fuzzy halo of gas and dust blasting off the solid nucleus. The tail, the solar wind, that constant stream of radiation from the sun, pushes that coma backward, forming a tail millions of miles long. On October 29th, at 1.4 AU, Atlas should have been at its most brilliant. We should have seen a massive coma. We should have measured a spectacular tail. We should have seen this comet light up. But what did we see? Nothing. This is what makes those 100 papers so frantic. It's not just that it vanished. It vanished at the exact moment that every law of physics says it should have been its brightest and its loudest. Imagine an opera singer stepping onto the stage for their biggest performance, taking a deep breath to hit their highest note, and then, instead of sound, just absolute silence filling the theater. That is not how comets work. Matter doesn't just stop interacting, unless it was never a comet at all. That spectacular cosmic dance where Atlas should have revealed its true nature under the sun's heat, we couldn't observe it. Why? For a reason that is both ironic and suspiciously convenient. When Atlas was at perihelion, Earth was on the other side of the Sunday. Our view of it was completely blinded by our own star. Imagine trying to watch a fireworks display, but someone parks a giant searchlight right in front of your face. We knew there should have been a show, but all we could see was the glare. Atlas slipped into the sun's blind spot at the exact critical moment. The impossible velocity. So how did we even know about it in the first place? Let's rewind. We've been tracking Atlas since July 2025. It was officially discovered by the Atlas system, the Asteroid Terrestrial Impact Last Alert System, a network of telescopes in Hawaii, Chile, and South Africa. Their job is to scan the night sky for moving objects. And on the night of July 1st, they found one. It was logged, classified as a new asteroid, just another faint speck among thousands. They were ready to move on. But then the algorithm started flagging. Something was wrong. It was moving too fast. This is where basic astrophysics comes in. Picture our sun as a gravity well. Everything in the solar system, Earth, Mars, the asteroids, is essentially trapped in this well. We are constantly falling toward the sun, but because we're moving sideways at such an immense speed, we continually miss and maintain our orbit. Our velocity is the velocity of prisoners in this system. Atlas wasn't. Its velocity wasn't that of a prisoner. Its velocity was that of an escapee. The rule is simple. To keep from falling into the sun, you have to move fast. The closer you get, the faster you must go. Look at our Earth at 1 AU, cruising along at 30 kilometers per second. Fast. But look at Mercury. It's weighing close at just 0.4 AU. To survive there, it has to bake itself and move at a staggering 48 kilometers per second. That is the hard speed limit for the inner solar system. Now, consider Atlas's data. When astronomers measured the velocity of this new asteroid, they were shocked. It was moving at 58 kilometers per second. Well, you might think 58 is only a little faster than 48. But here is the kicker, the key point, that sent a chill down every scientist's spine. Atlas was moving at 58 kilometers per second, while it was still way out, just inside the orbit of Jupiter, about 4.5 AU from the Sunday. Let me make this clear. At 4.5 AU, the sun's gravity is weak. A bound object, like a normal asteroid, should be moving slowly, maybe just 13 or 14 kilometers per second. Seeing Atlas move at 58 kilometers per second out there is like watching a kayak overtake a high-speed racing boat. It's a physical. That speed is just too fast. It far exceeds the sun's escape velocity. The data could only mean one thing. Atlas never belonged here. It wasn't in an elliptical orbit, a closed loop, like the planets. It was on a hyperbolic trajectory, an open-ended flight path. It came from interstellar space. And it was going right back there after this brief tour. This was our third confirmed interstellar visitor. And that's when the name Atlas, from the Discovery system, stuck. A third visitor, moving faster than anything we'd ever seen, and it was heading straight for perihelion, where it promptly turned invisible. You guys remember Oumuamua, one eye, right? The first visitor. It was weird. In its own way, its shape, the way it moved. Then we got Borisov, 2i, the often overlooked middle child. Borisov was actually not that weird. Other than coming from interstellar space, it basically behaved exactly like one of our own comets. Borisov was crucial because it gave us a baseline. It showed us what a normal interstellar comet looks like. And Atlas shattered that baseline to pieces. We are not talking about small differences. We are talking about fundamental level anomalies. Oumuamua was at most 400 meters wide. Borisov was about 1 kilometer across. Atlas, our data suggests, it could be up to 5.6 kilometers wide. This isn't a boulder. This is a small mountain. An object with significant self-gravity hurtling through our system. An object that large should have been the easiest target in the world to track. Instead, it's the one we lost. We said 58 kilometers per second was fast. Now let's put it in context. That is twice the velocity of both Oumuamua and Borisov. Pause for a second to absorb that. It's not 10% or 20% faster. It is in a completely different energy class. What kind of origin event launches a 5.6 kilometer object at that horrifying speed? And this is the one that keeps me up at night. This is the fringe data everyone is whispering about. Imagine our solar system as a car driving through the rain. The car, the solar system, is moving around the galactic center. The raindrops, the interstellar objects, are just hanging out there. Basic logic says you're going to get hit by more raindrops on your front windshield, the direction we're moving, than your back window. That is exactly what happened with Oumuamua and Borisov. Both came from the north, the general direction the solar system is hurtling toward. They were predictable, head-on collisions. But Atlas was not a head-on collision. This thing, it's coming from somewhere else. If Atlas's speed shocked us, its trajectory defied logic. The T-bone collision, remember what we learned. Oumuamua and Borisov were head-on, like bugs hitting the windshield of the moving solar system. Atlas was not. Atlas was a T-bone collision. It was coming in from the side, and this is where it gets deeply weird. Our solar system is fundamentally flat. It's a disk. All the material dust, gas, that formed the sun and planets settled into a relatively thin plane. We call it the ecliptic plane. The planets, the moons, the asteroids, we are all moving on this flat racetrack. Space, however, is three-dimensional. An interstellar visitor can come from anywhere from above the disk, below the disk, or any random angle. So where did Atlas come from? The data shows its trajectory is off by only 3 degrees from our ecliptic plane. Let me put this in perspective. Imagine the solar system is a single thin sheet of paper floating in a massive stadium. Atlas didn't dive at it from the stands. It flew in from the sidelines almost perfectly parallel to the surface of that paper. The probability of that happening by chance? It is near zero. This is a coincidence on a cosmic scale. And astronomers hate coincidences. It is as if this object knew the exact plane the planets move on and decided to fly right alongside it. Origin, the galactic core? So, if we trace this impossible trajectory back in time, where did it come from? The answer, the direction of the galactic core. If you look at a top-down map of the Milky Way, you see us way out in a spiral arm. The galactic core is that bright, chaotic center where stars are far more dense than in our neighborhood. Atlas appears to come from that direction, but again, that's a two-dimensional view. As we've established, space is three-dimensional. To truly understand where Atlas came from, we can't just look top-down. We have to flip our galaxy and look at it from the side, and that is when the truth gets even weirder. All right, we are flipping the Milky Way and looking at it from its edge. Just like the solar system, most of the material, the stars, the gas, sits in a crowded, chaotic, thin disk. But there's another region. Floating above and below it is the thick disk, a halo of much older, much sparser stars. Everything in the thick disk tends to remain undisturbed for a very, very long time. And that is where astronomers believe Atlas came from, the 7-billion-year-old traveler. What does coming from the thick disk tell us about it? It means Atlas could be extremely ancient. Estimates suggest it might have been wandering out there for as long as 7.6 billion years. Let me repeat that. 7.6 billion years. Our planet Earth is only 4.5 billion years old. This object is nearly twice the age of our world. This is where the data begins to defy our logic. Scientists did something incredible. They rewound Atlas's trajectory with its 58 kilometers per second speed on its T-bone path back 10 million years into the past. They wanted to see where it had been. During that 10 million year journey, they identified 93 star systems that Atlas encountered. But here is the kicker. In all 10 million years, and all 93 of those systems, the closest it ever got to any of them was 0.3 light years. Do you have any idea how vast 0.3 light years is? That is 63,000 astronomical units AU. Get this straight. In 10 million years, it grazed 93 star systems, but it always kept its distance a safe 63,000 AU minimum. It was just a visitor passing in the cosmic night. And yet, this 7.6 billion year old object, this thing that dodged 93 star systems at 63,000 AU, just flew past our solar system at a distance of only 1.4 AU. Do you see the problem here? It's like a 10 million year old hiker who always walks at least 100 miles away from every campfire, and then suddenly they decide to walk straight into our campsite and sit down just a few feet from the flames. The probability of that coincidence? Near zero. And that brings us to the actual observations. Because although Atlas was officially discovered on July 1st, that wasn't the first time we saw it. It was first spotted on May 7th, 2025. And what we saw in those first images, that's when the story gets really disturbing. Let's go back to those first observations, because the vanishing act at perihelion wasn't the first strange thing. The unnatural light, the T-bone collision, the 58 kilometers per second speed, the 7.6 billion year age, all of this we only learned after its confirmation in July. But we had earlier data. It turns out Atlas had appeared in images taken on May 7th, 2025 by TESS, the Transiting Exoplanet Survey satellite. And talk about luck. TESS is an Earth-orbiting observatory. It is not designed to hunt asteroids. It's designed to stare at distant stars, looking for the tiniest dip in light that signals a passing planet. But for about a month, TESS just happened to be looking in the right direction as Atlas moved past the orbit of Jupiter. This is where we get our first major contradiction. Astronomers had a hypothesis. Based on its trajectory, Atlas's brightness should have increased by a factor of 1.5 between May and June, simply because it was getting slightly closer. But what did the test data show? Its brightness had surged by a factor of 5. This massive increase in reflected light could only mean one thing at the time. It wasn't a dead rock, an asteroid. It had to be a comet that was starting to activate. The faint heat of the sun, even out at Jupiter's distance, was enough for it to start venting gas and dust, forming its first coma. It was this coma that was catching the sunlight and making it shine 5x brighter. Problem solved? No. This is where it gets truly weird. And there were two terrible anomalies with this observation. One, the polarization. When sunlight hits an object and reflects off, it gets polarized, it vibrates in a preferred direction. By measuring this, we can tell the texture and composition of the surface. Most objects in space, including our interstellar guest Borisov, have positive polarization. Atlas, it had negative polarization, and not just negative. It had the most extreme negative polarization of any object, comet or asteroid, ever detected in our solar system. Its surface was reflecting light in a way we had never seen. It had a texture that was alien at a physical level. 2. The impossible coma. The second staggering thing about Atlas's coma was the fact that it existed at all. Remember, we were looking at it at the orbit of Jupiter. Okay, this is where we go from weird to physically impossible and back again. Recall the contradiction. Atlas brightened by 5x, TESS observation. This implies it was forming a coma. But it was way out past Jupiter's orbit over 5 AU, where it is far too cold for H2O, water ice, to sublimate. So how does an ice cube vaporize inside a cosmic freezer? This is when we pointed our most powerful spectroscopic telescopes at Atlas. We weren't just looking at its brightness, we were reading the chemical fingerprint of that coma, and what we found changed the game entirely. That coma, it wasn't water. It was dominated by carbon dioxide, CO2 gas. Our data showed the ratio of CO2 to water vapor was about 8:1. To give you perspective, most comets in our solar system are basically dirty snowballs, lots of water, a little CO2. Atlas was the opposite. It was a massive, dirty, dry ice ball. If you've ever seen dry ice on a stage, you know what happens. The second it's out of its super cold environment, it immediately starts to smoke, sublimate. That is exactly what Atlas was doing in deep space. CO2 ice doesn't need much heat to sublimate. It melts at a much lower temperature than water ice. The faint sunlight, even out at 5 AU, was more than enough to make this 5.6 kilometer mountain of dry ice begin to erupt. This perfectly explained the 5x brightness surge. Mystery solved, right? No. This is where the modeler's nightmare begins. As we continue to watch Atlas on its journey as it moved from Jupiter inwards late August, September, we saw something even stranger. The ratio started to flip. As it got hotter, the amount of CO2, the easy-to-burn stuff, decreased because it was already burning off, and the amount of water vapor started to rise. This meant Atlas had both an outer shell of dry ice and a core rich in water ice. Now connect all the facts. It had a massive dry ice shell that erupted at 5 AU. It had a water ice core that began activating as it got closer. It was heading for its 1.4 AU perihelion, its hottest point. By all logic, by every law of physics, when Atlas hit perihelion on October 29th, it should have been an inferno. It should have been venting both leftover CO2 and massive amounts of water. It should have been one of the brightest, most spectacular objects we had ever seen. But you remember what we said, don't you? We saw nothing. It had vanished. It went invisible at the exact moment it should have been at its most brilliant. The dry ice explanation solved the initial mystery, but it created a paradox 1,000 times bigger. Okay, so we're at perihelion, October 29th, when Atlas dove into the sun's glare. It went in as a hyperactivating dry ice, CO2, and water ice, H2O bomb, and somehow it disappeared. But let's rewind just a bit to the last data we got before it vanished. Because its behavior was getting even stranger. The fire hose and the four-fingered fingerprint, we confirmed its dry ice, CO2, shell activated way out past Jupiter. Then, in late September, as Atlas crossed the orbit of Mars, something else flipped a switch. Suddenly, we registered a massive plume of water vapor beginning to blast off of it. Scientists don't like the word massive unless the data forces it. And it forced it. The water output was the equivalent of a full throttle fire hose, a solid jet of it, erupting into space. We have never seen water turn on like that, so suddenly and so violently, on a comet. It seemed the outer dry ice shell had finally burst, exposing the inner water ice core. But this controlled event wasn't the weirdest part. The weirdest part was the metals. The mystery metals, all through the summer, while Atlas was still far out in the asteroid belt, still freezing cold, we analyzed its coma. We detected nickel. This by itself was an anomaly. But what truly baffled us was what wasn't there. There was no iron. In astrophysics, nickel and iron are inseparable brothers. They form together in supernovae. They sink to the core of planets together. They are found together in most asteroids and comets. Finding nickel without iron is like finding a fingerprint, but with only 4 fingers. It immediately begs the question, what process separated them? Where did the iron go? Furthermore, why were we seeing any metal sublimating way out there where it was too cold? The most plausible hypothesis, the sane one, was that the massive CO2 dry ice explosion, the one that made it 5x brighter, was so violent that it dragged the heavy nickel atoms right off the surface. Okay, I'll buy that, but again, why did it only drag the nickel? And then late September arrived. At the exact same moment the water fire hose switched on, something else appeared in our spectroscopic data. Iron. For the first time, iron showed up. And very quickly, the nickel to iron ratio shifted, recalibrating itself back to a normal combination of both. So Atlas was becoming more normal over time, but it was doing so in the strangest way imaginable. It wasn't melting chaotically like a comet. It was activating in a sequence, layer by layer. Phase 1 distant. Co2 and nickel only, phase 2 closer. Sudden water and iron. It was like a machine executing a scheduled startup sequence as it approached our heat source. And just as that sequence hit its climax, it shut off the lights. Where in late September, Atlas is performing this bizarre startup sequence. First Co2 and nickel, the 4-fingered print, then a fire hose of water, and iron, the 5th finger appears. It's normalizing in the most abnormal way. And then we looked at its tail. The anti-tail, one of the most iconic images of the universe, is a comet. The bright head and the long brilliant tail always pointing away from the Sunday. Why? Because that tail is created by the solar wind. The solar wind is a constant stream of charged particles blowing off the Sunday. It's like a perpetual wind. A comet's tail, like a flag in that wind, always points in the direction the wind is blowing. And yet, when we first observed Atlas back in the summer, it had formed a tail that was pointing toward the Sunday. It was pointing the wrong way. Now, there is a sane explanation for this. Remember, Atlas started sublimating its massive CO2 shell when it was way out. At that distance, the solar wind was likely just too weak to push that heavy, dense cloud of gas and dust. So what we were seeing probably wasn't a true tail at all, but rather that CO2 cloud accumulating on the warm, sun-facing side of the object before the wind was strong enough to form a conventional tail. And sure enough, by September, as it got closer and the solar wind intensified, it grew a short, fan-shaped tail pointing away from the Sunday. Once again, Atlas corrected itself. Just like the nickel divided by iron ratio suddenly normalized, its tail suddenly normalized. Are you seeing the pattern here? It keeps demonstrating a physical behavior and then immediately covers its tracks by behaving just like a normal comet. But all those distant observations were nothing compared to what happened next. The Mars front row seat. Around this time, we got our closest, clearest look at Atlas. But that view didn't come from Earth. It came from Mars. On October 3rd, this 7.6 billion-year-old object, moving at 58 kilometers per second, made an extremely close flyby of the red planet. It passed Mars at a distance of only 0.19 astronomical units, AU. 0.19 AU. That is roughly 28.4 million kilometers on a cosmic scale. That is a near miss. And we were there. We don't just have orbiters around Mars. We have robots on the ground. we had our robotic eyes in the front row, waiting for this mysterious traveler to fly past. On October 3rd, right after it switched on its water fire hose and fixed its nickel divided by iron ratio, Atlas made its closest pass. Not by us, but by Mars. It flew past at a distance of just 0.19 astronomical units, AU about 28.4 million kilometers. This was the closest planetary approach of its entire journey. And we had cameras there waiting, part 13, the photos from Mars. This is one of them. It was taken by the Perseverance rover from the surface of Mars. This is not a good photo. Perseverance's cameras were not designed for low-light astrophotography. To get this image, the rover had to take a 30-second exposure and stack multiple shots. This is what Atlas looked like in the Martian night sky, a bright, strange smudge. We have another, slightly clearer shot from the European Space Agency's ESA Mars orbiter, image from orbit showing a slightly more defined but still fuzzy bright object. Here we can see it better. But it also reveals a problem. The resolution is still too low. We can't make it out. What are we looking at? Where is the 5.6 kilometer hard surface? And where is the massive coma, the one being generated by the dry ice explosion and the water fire hose? Everything is just one brilliant, mysterious halo. The actual object, the 7.6 billion-year-old core, remained perfectly hidden inside its own self-generated shroud. And these are the last images we have before it headed for the Sunday. After its Mars flyby, Atlas continued its unstoppable journey to perihelion, its closest point to the Sun, 1.4 AU, on October 29th. As I said, it went into the Sun's glare, and the silence fell. Right now, we can see nothing. We are blind. We can only wait. Time is what we have right now. Our star will continue to block our view until early December. By then, Earth will have moved far enough in its orbit for us to peek around the Sun and hopefully reacquire Atlas. On December 19th, we will get our next clear line of sight. At that point, Atlas will already be on its way out of the solar system. We won't be observing the object itself anymore. We'll be studying what the Sun did to it. Was it torn apart? Was its shell stripped away? Or did it simply shut down all activity and continue its journey as if nothing ever happened? But the encounter isn't over. The orbital data shows there is one last interaction, one final flyby. On March 16th, 2026, this object will fly within 0.36 astronomical units. On March 16th, 2026, Atlas will make one final flyby, this time not of Mars, but of the giant of our solar system, Jupiter. The orbital data shows it will pass within 0.36 astronomical units, AU, of the planet. Consider this, the 7.6 billion-year-old traveler, on its perfect 3-degree T-bone trajectory, grazed Mars at 0.19 AU, and now it's set to graze Jupiter at 0.36 AU. The odds of these coincidences are becoming absurd. We don't have a fleet of robots there like we do at Mars, but we do have one Sentinel, NASA's Juno probe. It spent the last decade observing the gas giant and its moons, but in March 2026, it will have the chance to pivot its cameras and take one last picture of Atlas before it vanishes into the interstellar void forever. By that point, Atlas will be cooling down. It will be less active, but it will be changed. We won't be looking at a pristine object anymore. We will be looking at an object that has just been baked by our Sunday. The scarring, the material changes, the way it cools, all of it will provide yet another layer of data on these interstellar visitors. This brings us to the final big question. A speculative one, but one based on everything we've seen. We have seen an object that has the strangest negative polarization ever recorded, has a massive CO2 dry ice shell that activated far too early, initially showed only nickel without iron, then suddenly switched on both iron and the fire hose of water at the same time, had a tail that initially pointed the wrong way, and vanished at the exact moment it should have been at its brightest. We've been assuming these are its original features, but maybe they're not. Remember, this object is 7.6 billion years old, nearly twice the age of Earth. It's entirely possible that many of these bizarre features aren't what it was born with from its nebula. They're simply an accretion of the weird things it collected along the way, over 7.6 billion years of wandering. Maybe it flew through the dusty remnant of an ancient supernova and picked up that nickel shell. Maybe it passed through a dark molecular cloud and accreted that CO2 dry ice layer. It's not a comet. It's an ancient relic. A cosmic collector wearing the fragments of 1,000 star systems it has passed through. And now it has taken a sample of our solar system with it. We started with a mystery object that vanished behind the sun's glare. We have to wait until December to find it again. We have to wait until March 2026 for Juno to get its final look. Until then, there's nothing else we can do. We can only wonder.